Hey guys, Miss Pipel here. In this video, we are going to be looking at examples of writing names and formulas for compounds when you have ionic compounds and covalent compounds all mixed up together. So this is going to be a video where it's just examples and practice. It's not notes. So if you feel like you got this, great, go ahead and turn the video off and get your practice done. If you feel like you need to watch all of the examples, by all means, keep watching the whole video. We're going to start by looking at kind of a flow chart of how to go about this process, because you need to kind of ask yourself a series of questions before you can actually write your name of formula based on deciding what type of compound you're dealing with. So when we're looking at this flow chart here, the first question we're asking ourselves is it a binary compound? For you, the answer is always going to be yes. Okay, binary means we have two pieces, and all of the formulas and compounds that you are going to be looking at for this class are all going to be binary for when you are responsible for writing names and formulas. Okay? So then, once we know that, which we always will, we're going to look at the second question, which asks us, is a metal present? Okay, if we ask ourselves, okay, what is a metal again? This is my rough sketch of a periodic table. Okay, if we have our stair step over here of the metalloids, okay, everything over here is a metal. So if you have an element present in your name or formula that is a metal, okay, you're going to follow this path, and that means you're dealing with an ionic compound. Okay, once you decide that you're dealing with an ionic compound, you're going to use the ionic system of naming and formula writing, where you either name your two ions or you find the ion charges, crisscross, and write the formula. Okay. You do also need to pay attention to the fact that you might have a transition metal in there. If you have a transition metal, you're going to be looking at this purple box down here where you have to include the Roman numeral in the name, or you use the Roman numeral to find the charge on the metal. Because those have kind of a variable charge when they're ions. Okay, if you don't have a transition metal and you just have group A metal in here, you're just going to find those charges or just name that element. Okay, if you don't have a metal present, if you have all nonmetals, okay, you're going to be using prefixes because you're dealing with a covalent compound. All right, so let's go ahead and go through some examples, and we're going to follow this process as we go. Okay, so our first couple examples are going to be writing formulas. So we're given the names, and we're going to need to write the formulas. So all of these are binary compounds, so we're going to go ahead and just assume that right off the bat. So our second question is going to be, is there a metal present? So if we look at number 1 here, I have beryllium oxide. Beryllium is a metal, and oxygen, which is what oxide is referring to, is a nonmetal. So that means this is an ionic compound. Okay, I'm going to abbreviate ionic with just an I. So we're going to use our ionic formula writing process. So I'm going to find beryllium on the periodic table. It has a charge of +2 because it lives in group 2. Oxide is referring to oxygen. Oxygen as an ion has a charge of -2. So when those two come together to form an ionic compound, they are going to come together in a 1-to-1 ratio because those charges just already even each other out. So that's going to be BeO for number 1. Okay. Looking at number 2, I have carbon tetrabromide. Couple of clues here. Carbon is a nonmetal, bromine is a nonmetal. So I have only nonmetals. So that means I'm going to be dealing with, this is a covalent compound. My other clue is that I have a prefix here of tetra. The only time we're going to have prefixes is when we're dealing with covalent compounds. So this one then, we're going to just write the formula based on what we're given here. Carbon without a prefix means I just have one carbon. Bromide is my second element, or bromine. And tetra means I have 4, so CBr4 is my formula for number 2. Looking at number 3 here, titanium 4 oxide. Okay, titanium is a metal. Oxide, again, is a nonmetal. So since I have a metal present, I am dealing with an ionic compound. So I'm going to use my ionic compound system. So I'm going to look at titanium and be like, oh wait, titanium is a transition metal. I don't know what its charge is, but that's what is given to you right here in Roman numerals. So that's going to be a +4 as its charge. Oxide, again, is -2 when it's an ion. Now we have to be careful here, because if I were to crisscross these, I would get Ti2O4. That is not correct because that is not a reduced ratio. We want to think about how many of each piece we need in order to make sure my charge is balanced. Or I can just reduce that crisscross there. So that's actually going to be TiO2. We can reduce 2 and 4 down to 1 to 2. All right. Number 4 here, this last example. Sodium nitrate. Couple of clues here. Again, we're looking at the types of elements. So sodium is a metal. So that should automatically tell me, that's my first automatic clue, that it's an ionic compound. My second clue is that nitrate is a polyatomic ion. So again, that means we're dealing with an ionic compound. So we're going to find sodium, write its charge. Nitrate has a formula of NO3 with a -1 charge. Okay, so I'm going to go ahead and just mush those together because they have the same numerical value for their charge, so they're going to even each other out just as is. So NaNO3. All right, so I have some more examples of these that I'm going to go ahead and write the answers to, but you can go ahead and try them on your own. So try these ones, go ahead and pause the video, and in just a second I will have all the answers up here on the screen for you. All right, so here are your answers for these examples. Okay, probably the most challenging one here, ammonium chloride. Technically, all of those would be nonmetals, but your clue is that ammonium is a polyatomic ion, and also the fact that you don't have any prefixes would clue you in that that's going to be an ionic compound. Okay, so now we're going to go ahead and do some practice going the other way. So seeing the formula and writing the name. Okay, so we're going to look at these formulas and determine which system of naming to use in order to match the type of compound that we're dealing with. So looking over here at number 1, CaCl2. So Ca is calcium. That is a metal. So that means we're dealing with an ionic compound. So when you name an ionic compound, all you need to do is name the 2 ions. You don't need to indicate how many of each there are, because that's assumed because we're dealing with charged pieces. So we're going to name our first piece, which would be calcium. And the second piece is chlorine, and then we always end our compounds with "ide" when we need to. So calcium chloride would be your formula, or excuse me, your name for number 1. Looking over here at Na3N, okay, we're going to do the same process. We're going to look at those elements. So sodium, Na, is a metal. Nitrogen is a nonmetal. So that means we're dealing with, again, an ionic compound. So in an ionic compound, we just name the 2 pieces. So the 2 pieces would be sodium. The second piece is nitrogen, but it's in a compound, so we call it nitride. We give it that married name of this is in a compound in a chemical bond with sodium. So sodium nitride there. Okay, moving on to NF3. N, nitrogen, is a nonmetal, and fluorine is also a nonmetal. So that means we're dealing with a covalent compound here. So we're going to need to use our prefix system. So the first element is nitrogen. There's only one of them, so we don't need a prefix on that one, nitrogen. Then our second element is fluorine, which we're going to end in "ide," and then we have to take into account how many there are. There are 3 fluorines. So the prefix to indicate 3 is tri, and then we're going to say trifluoride. So the answer there would be nitrogen trifluoride. Okay, and the last example here, CS2, carbon, nonmetal. Sulfur, also a nonmetal. That means we're dealing with a covalent compound. So where are you going to use our prefix system? So carbon is the first element, only one of those. We don't need a prefix to say that I just have one carbon when it's first. Then the second element is sulfur. We're going to make it sulfide because it's in a compound, and we're going to indicate that there are 2 by saying carbon disulfide. All right, so we're going to do the same thing where if you have, I'm going to put up some more practice, and I'll give you the answers in just a second. Okay, so go ahead and pause your video and try these ones on your own. These ones are a little more challenging, but I'll have the answers up in just a second. All right, so here we go. First one is sulfur dibromide. That's a covalent compound. Sulfur and bromine are both nonmetals. Second one, Fe2O3. We have a metal there of iron, so that's ionic. Iron is a transition metal, so we also have to include what its charge is. We uncrisscross to figure out that it's iron 3 oxide. Copper, and then 2 chlorates. Chlorate is a polyatomic ion. When you see 3 elements involved, you're automatically going to know that it's an ionic compound because only polyatomic ions allow us to have more than 1 or more than 2 elements in a binary compound. And so that means we have to be using the ionic system. So copper with a +2 charge in that situation. So copper 2 chlorate. And then lastly, magnesium nitrate. Again, a polyatomic ion tells us we're dealing with ionic compounds. Okay, so work on your practice, and you're going to have mixed ones of these on your test. So you want to make sure that you can use your context clues to figure out what type of element, or excuse me, what type of compound you have in each situation.